talking about, we've been saying the word function a lot, but we haven't really defined what a function is. So that's what we're going to get into in this lesson. So you've studied the relationships between input and output values, but what happens when the relationship gives you unpredictable results? That is, what happens when you cannot predict the output for a given input. Today we'll study this situation and we'll be introduced to the quality that makes a relationship an actual function. So the soda machine. So imagine a soda machine like you have here. Hopefully you can see there's 2 blasts, a slurp, a lemon twister, and a diet slurp. So I'm just going to put this over to the side. We have blast, we have blast, we have slurp, we have lemon twister, and we have diet slurp. Okay, so these are the 5 buttons. So the soda machine at your school offers several types of soda. There's 2 buttons for blast, while other drinks are slurp, lemon twister, and diet slurp. Describe the input and output of the soda machine. Well, the input, I don't know, it could be the change that you have to put into it, but really it's probably the button that you're pushing, right? That's kind of what we're looking at for the input. The output would hopefully be that soda. So while buying a soda, Miss Whitney pushed the button for lemon twister and got a can of lemon twister. Yay. Later, she went back to the same machine, again pushed the lemon twister, but this time she got a can of blast. Is the machine functioning properly? Or consistently, I should say. It's not consistent, right? If you press the lemon twister button, you expect to get a lemon twister, but even if you don't get a lemon twister, let's say you do get a blast, that would be fine as long as you always got a blast. That would still be consistent. It would be wrong, but it would be consistent, right? But the fact that one time she got a lemon twister and the next time she got a blast, that makes it inconsistent. Again, there's a difference between being inconsistent and being wrong. So when Brandy pushed the button, top button for blast, she received a can of blast. Her friend Miguel decided to be different and he pushed the second button for blast. He too received a can of blast. Each of them asked 5 friends to push the 2 blast buttons and they all got the same result. They all got a blast. Is the machine functioning consistently? Yeah, it's consistent, right? Every time you hit a blast, you get blast. Every time you hit a blast, you get a blast again. Not only is it consistent, but it's also correct. They are 2 different questions. Again, here we were saying inconsistent. And we were saying it was, half right, half wrong. Here we're saying, hold on, I'm sorry, I'm getting a call. Let me, almost guaranteed to repeat myself. I sort of lost train of thought while I was on the phone. But long story short, I think we were talking about consistent versus correct. So this one was inconsistent and it was half correct and half incorrect, right? So it was half correct. It was correct once and incorrect once. This one was consistent and correct. Consistent. And it was correct. Here's an example. Lautfi pushed slurp and she got a lemon twister. Later, Letitia pushed slurp and got a lemon twister. Later, Taisha pushed slurp and got a lemon twister. So this one is consistent, right? It's just incorrect. So I hope we see the difference between consistency and being correct or not. And really, the consistent part of it is the one that we're more concerned of than the correct part of it. So just to kind of set up what we're going to head to. So functions. In a relationship like a soda machine, we want the output to be consistent and predictable. So again, accuracy doesn't really have much to do with it, but consistency does. I want to know that when I push, like in this example, if I push slurp and I get a lemon twister, once I know that, that's fine. Right? I know that if I want a lemon twister, I push this button. It's not that big of a deal once I know that it's consistent. The problem that I have is on this first one, that if I push lemon twister and I don't know what I'm going to get, that's when I run into the trouble, right? If I push blast, I get a blast, that's great. If I push slurp and I get a lemon twister, that's great. At least I know what I can expect. But when I push lemon twister, half the time I get one, half the time I get another, that's a problem. So when it's consistent, it's a function. When it's inconsistent, it is not a function. And let's take a look at that. So here, if I push 1, I get a sticks. If I push 1, I get a sticks. If I push 2, I get an M&N or a dud. That's not consistent, right? The fact is, for each input, each input can only have one output. That's a function. So again, I want to look at this. I put 1, I get a sticks. I push 1, I get a sticks. That's consistent. When I push 2, I get an M&M. When I push 2, I get a dud. That is not inconsistent. I do want to say this though, because I think some people don't really see this. Let's pretend that this isn't even part of it. Let's pretend that's not even an option. Now if I press 1, I get a sticks. If I press 2, I get an M&M. If I press 3, I get a dud. And if I press 4, I get an M&M. Well, that is consistent. Even though I can get an M&M, 2 different buttons, still each button only does one thing. And that's what makes it consistent. Where it loses its consistency is right here, where this button does 2 things. And that's the inconsistency. So this would not be a function. This one. If I put a 7, I get a 6. If I put a -2, I get a -3. If I put a 0, I get a 4. If I put a 4, I get a 2. If I put a 9, I get a 10. A -3, I get a -3. A 6, I get a 0. Each of these buttons only gives me one output. So yes, this one is a function. Here, if I press a 3, I get a 4. A -1, I get a -5. A 2 and a 9, and a 2 and a -8. Look at that. Not a function, right? That's inconsistent. If I press a 2, I don't know what I'm going to get. Here, if I press a 2, I don't know what I'm going to get. I do for all the rest of them, but I still lose the consistency on 1 and 3 by pressing 2. So those two are not functions. So a relationship between inputs and outputs is called a function if the inputs and outputs behave like a soda machine that is functioning properly. Again, that it's consistent, that you always get the same one. So we're going to go ahead and close this and then reopen it and finish this up. So now it asks us to look at graphs and decide if it's a function or not. So no problem. If I plug in -3, I get a 1. If I plug in a -2, I get a 3. If I plug in a -1, I get a 1. If I plug in a 1, I get a 1. A 2 is a 3, and a 3 is a 3. There's no inconsistencies here, so this one would be a function. This one, though, think about it. If I plug in a 1, I don't know if I'm going to be here, here, or here. I have 3 options at 1. I have even more at 0. I have 1 there, 1 there, 1 there, 1 there, 1 there. This one is not a function, which, by the way, brings us to something called the vertical line test. And here's what the vertical line test is. The vertical line test says this. If you have, I thought this would look better than it does, so I apologize. I guess if you run a vertical line across the shape, the question is, how many points does this pick up? Here, a vertical line hits more than one spot, so it's not a function. On this one, a vertical line only hits one at a time, right? Hits one there, hits one there, hits one there, hits one there, there. So this one is a function. I guess I'm going to skip 6 for a second and go to 7. This one does pass the vertical line test, right? Every single time, every single input that you give me, I have exactly one output. If I plug in this number, I get the output here. If I plug in this number, I get one output. Here, one output. Here, one output. Here, one output. So this one is a function. And then here, let's take a look. If I press -8, I get an 11. If I press -8, I get an 11. Well, that's consistent. If I press a 4, I get a 3. An 11 is a -8, and a 6 is a 3. That's great. So this is a function. And again, I just want to talk real quickly. Some people say, well, no, look, you can get 3 twice. Yeah, it doesn't matter. You can go here, right? And I can, if I graph this thing, -8 is 11, 4 is 3, 11 I get -8, 6 is 3, and -8 is 11. That's fine. Every time I hit -8, I get an 11. I did it twice. That's consistent. Here, who cares if I get a 3 2 times? When I press a 4, I get a 3. When I press a 6, I get a 3. That's totally fine. Popular deal here today. So anyways, this one is a function. I know I went on and on about that one. And finally, Jade noticed that the line graphed at right is a function. Hey, I think all lines are functions. Well, that's reasonable to think all lines are functions. However, there is one line a vertical line is not a function because at this input you have infinite output. So she's almost correct, but not quite. And I hope that makes sense why this is not a function. But all other lines are functions. Just that one isn't.